having a good day, evening, morning, whatever it is. We're switching gears now. We're kind of done dealing with systems of equations, and we're gonna move on to properties of exponents. So we're gonna start with multiplication property of exponents. Hopefully, you guys are familiar with an exponent, but if not, the power in general and how an exponent works and the parts of a power and whatnot. We're gonna go through that first, and then we'll talk about three multiplication properties of exponents that you guys need to know as eighth graders, and in future math classes it will also be very useful. So we're going to kind of talk about that now. So just go ahead and take free form notes on these, and if you're doing this asynchronously, the expectation in class is that we'll do the examples together. So just go ahead and stop when you get to the examples. If you're watching this on your own and you miss class, I'd just go ahead and watch the whole thing. All right, let me go ahead and jump into it. Okay, multiplication property of exponents. First thing, we need to talk about what a power is. So a lot of times people will interchange the word power and exponent. They're not the same thing. So a power is the combination of both the base number, right? That's whatever number is repeated, and the exponent, which tells you how many times you're going to repeat that number. The power is the whole thing. A lot of people kind of get exponent and power mixed up. Just keep that in mind. So right here we have 3 to the 4th power, right? Now if you expand that out, what that really means is 3 times 3 times 3 times 3. So that's really all a power is a way of simplifying expanded form. There's also some cool tricks we can do with it, which makes math a lot easier. All right, so as already stated, that right there, that would be read as 3 to the 4th power. There's 2 exceptions you guys need to know where you say it slightly differently. And that would be if something is, like say we had 3 squared, we just say that is 3 squared. Or if we had, let's say we had 4 to the 3rd power, we just say that's 4 cubed. So squared and cubed we say differently. Everything else we're going to say blank to the blank power. So just keep that in mind. There are some kind of caveats and exceptions to it. But generally speaking, you're going to read this as whatever the base number is to the whatever the power is, whatever that exponent value is. Okay, so 3 to the 4th power. Okay, let's look at some of these properties. Now, these might not make sense when we're going through the actual properties. Hopefully by the time we're going through examples in class today, you'll get it. So the first one is product of powers. So product means we're multiplying 2 things together, right? So to multiply 2 powers with the same base, you're just going to add the exponents. So if we want to really think about this, let's throw some numbers in here real quick. Let's say we had a to the, I don't want to use that big fat pen. Let me use that. There we go. Let's say we wanted to say a was to the 3rd power, and we're multiplying that by a to the 2nd power. Really what we'd have, a to the 3rd power is really a times a times a, and then a to the 2nd power would be a times a. So really what we're doing is we have a to the 5th power, so we're just going to add those up. Okay. Next one, power of a power. To find the power of a power, multiply the exponent. So basically, we have a power, and then we're raising that. We have an exponent, and we're going to raise that to another exponent. So the rule is just multiply those 2 exponents together. The reason why that works, let's go ahead and use a again. Let's say we had a to the 3rd power raised to the 2nd power. That really means what we have is a to the 3rd power multiplied by a to the 3rd power. The exponent squaring that just says we have this 2 times. So now if we expand that out again, that just really means we have a times a times a, and then right here we have 3 more a's, times a times a times a. So now we have 1, 2, 3, 4, 5, 6. 3 times 2 is indeed 6. So another way of looking at it. All right. The next one is the power of a product. So to find the power of a product, find the power of each factor and multiply. So we kind of want to deal with each of these different terms on the inside separately. We want to deal with a and b separately. So really what we want to do is make sure we're multiplying whatever's on the inside with whatever's on the outside. Now, a lot of students with this particular one, I like you guys to think of this as being a 1 right here. If it does not have an exponent, it will always have an exponent of 1. So 1 times n is n, 1 times n is n. So it's another way of looking at it. You just have to make sure that that exponent on the outside is being applied to everything on the inside. It's really similar to the distributive property, but it applies only to exponents. All right, we're going to talk about what a simplified expression should have. Okay, each base appears exactly once. So what that means, if you have a letter like an A or a B, whatever that might be, you're only going to see it one time. No power to powers, so anything like right here, when we look at our power to power, the quantity of a to the nth power, we want to get rid of that. We want to make sure we simplify that fully. No numeric values of powers. So let's say we had 5 squared. Instead of writing down 5 squared, we should write down 25. We should go ahead and simplify that and just turn it into whatever it is. And then fractions written in simplest form. So a lot of students will forget this step. Let's say you have like 8 a to the fourth over b to the second. We'll talk about this when we get into division. But if we had a fraction here, we could simplify the 8 divided by 2 to 4. And if we were to flip that and say it's 2 over 8, we could simplify it to 1/4. So just make sure you're simplifying the fractions all the way. So, you know. All right, let's go ahead and move on. Let's look at some examples. So if you're taking notes in class and you're planning on going over this with myself or Miss Olson, you can go ahead and pause here. Make sure you have all this down up above that in your notes, and then we're going to go over these with you in class today. Okay, if you miss class and you're like, or kind of zoned out in class, or you're previewing it, or for whatever reason you're still watching the video, we're going to kind of go through these now. And of course, my OneNote has to bug out on me right before I start. We're just going to kind of work through that. You guys, oh, there it is. All right, so first thing I like to do when I'm looking at these, especially when I'm with new students, is go ahead and encourage everyone to make sure everything has an exponent. So exponent, exponent, exponent. This doesn't. So if it doesn't have an exponent, just go ahead and add a 1 to it. So there's no power of powers here. All we're dealing with is product of powers, right? So in this case, if they have the same base, we're just going to add those exponents up. So let's go ahead and look at this. So start with the y's. So I have 3 y's here, 6 y's there. That'd be y to the 9th power. And then x's, I have 2 there, 1 there. That'd be x to the 3rd power, or even better, x cubed. So remember, if you're looking at no power to power, you're just trying to find the same bases, and then you're going to add them together. Okay, that's it. We can't simplify it any further. That is your final answer. You might see some people like ordering your variables in alphabetical order. Doesn't really matter. All right, now the second one we're looking at, like this is an example of a power of a power, right? It's got a little bit of product power of a product built into it as well, because we have multiple things we're looking at the same time. And of course, my OneNote's bugging out, but we're just gonna ignore that for the time being. So make sure, like just in the last one, make sure all of your variables have an exponent assigned to it. In this case, the b does and the w does as well. So what we're doing here is we're going to multiply both of those by the 4 on the outside. So remember that what this really means is we have b cubed w squared 4 times. So instead of writing it out 4 times and then adding those exponents up, we can do this a little bit quicker by just simply multiplying the exponent on the outside by the exponents on the inside. So 3 times 4 is 12. So we have b 12. 2 times 4 is 8. So if you're wondering, like, Mr. Robinson, how does that work? Just a quick reminder, this 4 indicates that this is repeating 4 times. So what we really have is b3w squared times b3w squared times b3w squared times b3w squared. Now this is the only time I'm going to do this, so I'll probably do this in class as well. That means that we have b w w times b w w times b w w times b w w. Now at this point, the dots indicating multiplication are just kind of formality, because all this is multiplied. So I mean, if I were to count the b's now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hence the 12. Same thing with the w's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I don't want you guys to do what I did over here over and over again. That is a waste of time. That's why we have these rules, right? To simplify our life and make it easier to do. So just keep that in mind. All right. Now let's look at the next one. Oop, hopefully my OneNote will catch up and not be a brat, but it might. Such is life. All right, so let me just drag this over a little bit. I'm sure this will disappear as soon as oh, there we go. So you just have to drag it over and then it disappears. Technology, great. All right, now this time we really want to treat this a little bit differently. So what I want to do is I want to multiply the 5 and the 2. And I also want to deal with these exponents. So what a lot of students will do when they're dealing with something like this is I'll see the trick with the exponents is to add them together, right? That doesn't work with 5 times 2. You just multiply 5 times 2. So what I see a lot of students do with these is like, oh, there's a trick here. I add them together. And they just kind of get in that thinking. Instead of multiplying 5 and 2, they'll add them up. So they'll give me this as an answer. This is probably one of the most common mistakes I see with multiplication property of exponents is kind of getting your wiring crossed. When it comes to what you do with the coefficients, we treat them like we always have. 5 times 2 is still 10. So that is wrong. The correct answer would be 10p to the 7th power. All right. Okay, cool. One more problem to go over. I guarantee when you're looking at your homework assignment tonight, you guys are going to be running into problems that are extensions of these. So take it slow. I mean, break down the component pieces before you move forward. And I'm sure Miss Olson and I will be answering multitudes of questions on this. All right, so this one has a lot going on. So I'm going to go ahead and just underline the things that kind of interact with each other. So the coefficients do, and then my x's are going to interact with each other. There's only one y, which is kind of convenient. And then we have a z on both sides. Okay, so I'm going to start by multiplying 3, 6, and 3. So that gives me 18. Okay, now I'm going to go ahead and deal with the x's. So I have x squared and then x to the 5th power. That'd be x to the 7th. 2 plus 5 is 7. Okay, I only have one y. So honestly, I can just write it down. No reason to wait. It's done. Nothing to add to it. And then finally deal with the z's. So z, I have 3 here, 2 there. That'd be z to the 5th. Okay, that's a quick introduction to the multiplication property of exponents. I hope that was useful. If you have questions, make sure you contact myself or Ms. Olson, and have a great day.